Hi, Assalamualaikum. My name is Wahida binti Hashim. Today I would like to present about two experiments. The first experiment, positive shear force and negative shear force. And then the experiment number 2, the positive bending moment can call as sagging and the negative bending moment can call as hogging. Now, I want to show you about experiment 1 and experiment 2. Okay, from the experiment 1 shear force, let's find the bending moment. What will happen when the load is between B and C, D and C, and A and B. For experiment 2, first, when the point load W is applied between B and C, the bending moment shall always be negative. Second, when the point load W is applied between A and B, the bending moment shall always be positive. Let's join to experiment 1 and 2. This is apparatus for experiment 1 and 2. Label A, hanging up, B, point B and D. Situation 1. Let's find out what will happen when the load is positioned between B and D. This is a length. This is a point A to B, B to D, D to C. Point A, B, D, and C. This is an intersection, X to X, reaction B and reaction C. Put the load between B and D. Calculate the reaction RB. Push down the load. Draw the shear force diagram. The shear force always be negative. For the bending moment, point B and D, push down the load. Draw the bending moment diagram. The result will be positive bending moment called as sagging moment. This is a true result for shear force diagram and bending moment diagram for point B and D. Situation 2. Let's find out what will happen when the load is positioned between D and C. Point D, point C. Intersection shear force. Put the load between D and C. Push down the load to reaction RB. Calculate the reaction RB. Push down the load and then draw the shear force diagram. Shear force shall always be positive. Experiment 2. For the bending moment, point D and C. Push down the load to reaction B. Push down the load. Draw the bending moment. The result will be positive. Positive bending moment called be sagging moment. The true result for the shear force diagram and bending moment diagram for the point D and C. The last situation, let's find out what will happen when the load is positioned between A and B. Point D intersection for shear force. Put the load between A and B. Push down the load. Calculate the reaction RB. Push the load. Draw the shear force diagram. shear force diagram always be positive. Bending moment. For experiment 2, for the bending moment point A and B, push down the load to reaction RB. Push down the load, calculate the reaction RB, draw the bending moment diagram. The result will be negative bending moment called as hanging moment. And the last, this is a true result for shear force diagram and bending moment diagram for point A and B. Detailed instruction for shear force. 1. The previous 3 slides show whether the measured shear force will be positive or negative when the applied point load is placed at different parts of the beam. 2nd, knowing the location of the point that will cause the measured shear force at X to X to be positive, place the load W at the place such that the measured shear force at X to X will be positive. Plot the shear force diagram and compare the shear force at X to X obtained from the shear force diagram with the measured value of shear force at X to X. 3rd, knowing the location of the point that will cause the measured shear force at X to X to be negative, place the load W at a place such that the measured shear force at X to X will become negative. Plot the shear force diagram and compare the shear force at the X to X obtained from the shear force diagram with the measured value of shear force at X to X. Detailed instruction for bending moment. First, the previous 2 slides show whether the measured bending moment will be positive or negative when the applied point load is placed at different parts of the beam. 2nd, knowing the location of the point that will cause the measured bending moment at X to X to be positive, place the load W at the place such that the measured bending moment at X to X will be positive. Plot the bending moment diagram and compare the bending moment at X to X obtained from the bending moment diagram with the measured value of bending moment at X to X. 3rd, knowing the location of the point that will cause the measured bending moment at X to X to be negative, place the load W at place such that the measured bending moment at X to X will become negative. Plot the bending moment diagram and compare the bending moment at X to X obtained from the bending moment diagram with the measured value of bending moment at X to X.